Hi, my name is Alex, and my project involved an assessment of factors influencing nitrogen use efficiency in major cereal crops. To start off, the background, you see there's a increasing demand of food by growing population, and cereals, which are a major uh, form of crops consumed worldwide, there is need to intensify agricultural production of these kind of crops to ensure that there is increased production to meet this demand uh, with the limited availability of land. So nitrogen is a limiting factor in crop production, and this would mean addition of this nutrient to supplement what's in the soil. But usually we see excess application, which leads to increased input costs to the farmers, as well as increased system losses that reduce nitrogen use efficiency. And when we have these system losses, then there's environmental degradation, whereby you have different forms of nitrogen into the environment, like nitrous oxide, which depletes the ozone layer. And also we have nitrates, which would leach to water bodies, causing eutrophication. And then we have ammonia, which leads to air pollution and formation of acid rain. So the aim of this research was to identify major environmental, soil, and management factors that would have an effect on grain yield and grain nitrogen response to applied nitrogen, and then using these factors to assess how they influence nitrogen use efficiency in the three major crops under investigation. That's rice, wheat, and maize. These are the major cereal crops consumed globally. Successful identification of these factors would provide us with an opportunity to optimize farm management practices to ensure that there is efficient usage of nitrogen by the plants. And this knowledge can then be applied even in other cropping systems. How I carried out this research was I started with a systematic keyword search in Web of Science, Scopus, and Google Scholar. And I was looking at studies that reported nitrogen use efficiency in the three major cereal crops mentioned before. And this study was done between September 2019 to February 2020. And it yielded 500 studies, which I then filtered by considering only those studies that had a control treatment or reported nitrogen use efficiency direct, or they had some parameters that would enable calculation of the nitrogen use efficiency. So from those, I got 72 publications, and in total 801 observations which I used in the meta-analysis. So this is just an overview of the distribution of studies in different countries, in different continental regions. And these, the countries highlighted in green are the ones that the data was obtained from in the studies, and represent 17 countries in total. There are different ways of the defining nitrogen use efficiency, and how I defined this in this study was this: the increase in plant biomass or grain nitrogen content from the control to the fertilized treatments divided by the amount of nitrogen fertilizer applied. And then we had these three components which represent nitrogen use efficiency that I used: above ground recovery efficiency, grain nitrogen recovery efficiency, and agronomic use efficiency. For the meta-analysis, the effect size was measured by looking at the ratio of now the natural log of mean value of fertilized treatments and the mean value of the control treatments. Starting off with the environmental factors, I did a correlation between mean annual temperature and grain nitrogen recovery efficiency, whereby you see there was a negative relationship. And this could be because increased temperature shortens the grain filling period. And this then would lead to a lack of synchrony between plant demand and nitrogen availability. Again, because of temperature-dependent nitrogen transformations, then there's increased loss due to denitrification. And this again reduces the amount of nitrogen available for the plants. Going to the soil factors, I tested this through a meta-analysis and looking at pH and soil organic carbon, and also the nitrogen use efficiency. So I noticed there was a higher crop grain yield response and grain nitrogen response at near neutral pH. And this was also the case for nitrogen use efficiency, as shown here. Near neutral pH had the highest values. Going on to soil organic carbon, which is closely related to soil organic matter. Now we also had a negative relationship, and this is because soil organic matter is a source of nitrogen, and this nitrogen, well, a source now into the soil would reduce the response due to the applied nitrogen from fertilizer. Going on to management factors, I tested this looking at fertilizer application rate and fertilizer application frequency. And starting with the rate, there was also a high grain yield response at low nitrogen for rice and maize. And this was at fertilizer applications below 100 kilograms nitrogen per hectare. Also, this was translated for nitrogen use efficiency values tested through above ground recovery efficiency and agronomic use efficiency, where low applications had the highest nitrogen application values. Looking at application frequency, this was different for different crops, but on overall, two split applications had the highest grain yield response. But when now you look at individual crops, then these differed between different crops. Although it looks like maize and wheat had the highest at 3 split applications. For nitrogen use efficiency, a single split application yielded the highest nitrogen use efficiency. But if you pay attention to the 6 split application, the study was only for one publication or one study on maize in China. So that would not be conclusive. The key findings from this study is that mean annual temperature had a negative influence on accumulation of grain nitrogen as tested by grain nitrogen recovery efficiency. And this could be attributed to the shortened grain filling period or nitrification losses. The best overall crop response was achieved at near neutral pH, that's between 6 and 8. Soil organic carbon, which was a source of nitrogen due to its association with soil organic matter, lowered the overall nitrogen use efficiency. There was increased application rates of nitrogen, reduced nitrogen use efficiency, and this can be explained because you have fertilizer application being a function of nitrogen use efficiency. So when you have more applied nitrogen, which is not fully utilized by the crops, then that means there's lowered or reduced nitrogen use efficiency. For the rice and maize studies, we saw they were over-fertilized, and this can be explained here. So we are having low application rates below 100 kilograms nitrogen per hectare, yielding or giving the highest response. But then we have high applications which do not give high grain yield response, meaning those studies could have been over-fertilized. And then high uptake of grains does not necessarily translate to increased yield. Again, the same graph explains, because we have grain nitrogen here, which had a positive relationship with application rates. So high application rate had high response, but this does not necessarily translate to the same even for the individual crop. So meaning there's a lack of association between accumulation of grain and the grain yield. Finally, grain response to application frequency was crop dependent. As shown here, there was different grain yield responses to application frequency, and this could be because these applications or the nitrogen use efficiency would be timing would be a major factor, because if it coincides with plant demand, then you're able to have a lot of nitrogen being uptaken. And this happens at different growth stages for different crops. In conclusion, there was a significant influence from the tested factors, environmental, soil factors, and management factors. which influenced grain response to application of nitrogen. And these were tested by looking at mean annual temperature and looking at pH, soil organic carbon, application rate, and application frequency of nitrogen, which showed either positive or negative relationship in the crops investigated. There's a potential for other factors to also influence nitrogen use efficiency, such as precipitation, which is an environmental factor, soil texture, which is a soil factor, and other management practices, such as where you get the nitrogen from. Is it nitrate based? Is it from other compounds? And these could be interesting to also investigate and see how they would affect nitrogen use efficiency. Uh, Overall, this study can be used to optimize agronomic decisions, and this would more specifically be on how you manage a nitrogen fertilizer application, and it can also be translated in other cropping systems. Those are my references, and thank you for listening.